This is the routine for in the tick of time. It starts out by getting an XY position, color, and a font to put the heading in the text of time on the screen. Then next, it loads the control registers 310. Well, that's unique to this routine because this is subprogram 3, tab 10. So it's going to get its unique control registers. Next, it says put the time in T. Then it says compare the time to what the time was previously. It can do that because before this routine ends, it's going to put the current time in the control register question mark. It doesn't want to do this routine every time it comes here because it only has to be done once for each play of the game. So it says, well, if you did this last time, go to BA. Well, if you haven't been here last time, well then we're going to build the frequency tables and do the probabilities. First, we're going to reset the probability distributions. Then we're going to start our first frequency table. We're going to say there's 40 different outcomes, but each one here we're going to say occurs 4 times. The frequency of each one is 4, so there's 160 outcomes in total. Here it says fill 40 values at frequency plus 2 with 4. Now it's going to use that frequency table. It's going to say for I of 0 to 159. Well, that's 160 times. And this is a puck. It's going to pick each one just one time, and then there are none left. So it's unreplaced. That's what the U is for, unreplaced. So there are only 160 possible outcomes. Since there are 40 shoots in our game, it's going to have each shoot there mentioned 4 times because we said the frequency was 4. So this index list is going to have 160 values in it. It's essentially what shoot is going to drop boxes next. Alright, then we're going to go to another frequency table because we want to know how many boxes are going to be put on the shoot each time for the 160 times. Well, first we're going to say that there's only 3 possible outcomes for this, and that is that 1 box will be dropped, 2 boxes, or 3 boxes. And here's their frequency values. And the total number of possibilities is 160. So now we're going to go around a loop for each one of those indexes and build another list called slot. And in slot there's going to be 2 values for that particular shoot if that random number that it picks here on this puck tells it 2 boxes. Well, let's look at this puck instruction. It says go and you get the this frequency table and pick a value for n. N is going to be 0, 1, or 2. Well, but that's not what we want, so we add 1 to it to get the box count of 1, 2, or 3. Now we're going to go around this loop of j from 1 to that value of n, and we're going to put we're going to repeat the index number for the number of boxes to be dropped. For instance, if it picks shoot 5, this new list is going to have 5, 5. if it says, well, pick this particular one just one time, say it's 15, it'll just be number 15. If it's 3 times and it says shoot 7, it'll be 777. So this list of slot is going to be longer than index. And because we selected the frequencies up here, we know that the average value of n is 2. So we know that this list called slot is going to be twice as long as index. So this list is going to be 320 values long. Right? This is as far as we're going to go on understanding this routine. We're now going to go and run in the tick of time. Now you see the routine in action. You're looking down on a conveyor belt where the boxes get placed. There are 20 chutes here and 20 chutes below, so there's 40 chutes. When a box comes out of the chute, it will be the color of that chute. We know that the list called slot determine which colored box would be on the conveyor belt. But at any one time, only 24 positions of slots is being shown. 20 for where the chutes are, and then 4 past there are being shown. The program makes sure that no box will show until it has passed its chute. This is the end of the video in the tick of time.